This is the first assignment in for the fourth quiz in the first trimester. So this assignment will be dealing with, there's my advertisement again, reducing square root expressions. Okay, and this is just a little bit annoying, but it's a lot of this unit is going to be setting us up to solve quadratics via the quadratic formula. So we have to have these skills. And like I said, this is more of just kind of an annoying unit of getting these skills down. But you're going to want to print out these sample notes here. And there's a nice little paper here for those of you that are a little bit challenged with technology that you can refer to looking up the reduction of square roots. So get those printed, and I will show you the idea here. I don't expect you to do all of these, but you have a good number that you can go back to and practice. And it's the simplifying, again, that's part of the quadratic formula. So you want to figure out in any square root that you're reducing, what is the largest perfect square root that will go into the problem. So you're looking at this list of numbers here. Let me get to the, and it could even be off the list of numbers. And so you're looking down this list here of values on the simplifying radicals page of notes. So 81 is going to be that largest one that will go into 162, and it's real important that you pick the largest value, and then from there you're just going to simply do the math. So that's 9, I always write them right above there, and then you multiply those two values together. So there's a rule in multiplying. You can multiply what's underneath square roots. There you go, 162, and you can multiply together numbers that are sitting outside the square root. You can add together square roots. We're going to get to that in a little bit. That have the same indices. But we're going to do sum of each. Keep in mind that you should always check out, hey, is this a perfect square root? That one is. Now, if you get stuck, you can look up the reduction. So what I mean by getting stuck is you can't figure out the largest perfect square that'll go into 192. Then look up if it's on here. Now, not all is on here. This one is 8 times the square root of 3. So 64 is the largest one that will go in. And I got that by looking up 8 times the square root of 3. If you have that page of notes and some good technology, actually the best thing is this page here. If it's on the page, your square root simplifying work will be pretty simple. Again, there's lots of problems to work through, and I'm just going to jump around here. So 72, the largest perfect square that will go into that is 36. And so you break it apart by just taking that product, 36 times 2. So 6 times the square root of 2 all over 3, and then do any reducing from there. I need to back out a little bit here. Do any reducing from there that you need to do. You're going to have this, again, why are we doing this? We're doing this because you're going to have to do this in dealing with the quadratic formula, which is the by hand way, one of the two by hand ways we have of getting x-intercepts in a quadratic. The other is completing the square. So 98, the largest perfect square there, I believe, is 49. So 7 times the square root of 2 over 14. So square root of 2 over 2 is that reduction. So you divide, just as you multiply numbers, that are outside the square roots. You divide numbers that are outside the square roots also. So I'm just hopping around giving you a variety of problems that need reducing. So square root of 28. Now I'm going to just go and look this up. That's 2 times the square root of 7. Square root of 88 is 2 times the square root of 22. So it was 4. And then this was also 4. 4 is a pretty popular one. And then square root of 112 is 4 times the square root of 7. So there's the 2 times 4 times the square. So 16 was the largest perfect square that would go into that. So we have 6 times the square root of 7 minus 8 times the square root of 7. That's negative 2 times the square root of 7 plus 2 times the square root of 22. And so you combine these, like they're like terms. Okay, so they both have the square root of 7, so you add those together, and that gives you that final answer there. Okay, and just when I wanted to get organized here, there we go. Yep. Okay, and then finally this last one, this is how we're ultimately going to see this. You're going to have this quadratic looking expression, and then square root of 50, I'm just going to jump to, that's 5 times the square root of 2 over 5. You're ultimately going to, it's going to look like this, and then you're going to have to look at these 3 values here. What will go into 10, 5, and 5, the largest number, and that's a 5. So that makes this a 2, 1, and a 1. So this is 2 plus the square root of 2 over 1, which we're not going to ever write over 1. But that is what that reduces to. And that's a good way to end for the next lesson, which is the full-on practicing of reducing these expressions. And then we're going to get into imaginary numbers. So what if that said the square root of negative 50? Then we're going to tack an I on the end of that and the study of those. And then in the next quiz, we'll get into solving quadratic expressions.